In the spring of 2021, when NASA's Perseverance Mars rover began analyzing rocks on the floor of the Jezero crater, scientists were taken by surprise. Because the crater originally had a lake billions of years ago, scientists expected to uncover sedimentary rock, which would have formed when sand and mud settled in a once aquatic environment. Instead, they discovered that the floor was composed of two types of igneous rock, one from magma deep beneath and the other from volcanic activity at the surface. Hello everyone, and welcome to another video. In today's video, we're going to discuss what NASA reveals about a new major discovery on Mars. Stay tuned to find out. So, let's start our video. 4 new publications describing the findings were published on Thursday, August 25th. In Science, one article describes Perseverance's research of the crater floor before its arrival of the Jezero's ancient river delta in April 2022, while another article in the same magazine describes rocks that appear to have originated from a thick magma body. The other 2 publications, published in Science Advances, describe the unusual methods by which the rock vaporizing laser and ground penetrating radar of the Perseverance spacecraft determined that igneous rocks blanket the crater bottom. Igneous rocks are good timekeepers, as crystals within them preserve the precise time of their formation. One great value of the igneous rocks we collected is that they'll tell us about when the lake was present in Jezero. We know it was there more recently than the igneous crater floor rocks formed, said Ken Farley of Caltech, Perseverance's project scientist and lead author of the first of the new science papers. This will address some major questions. When was Mars's climate conducive to lakes and rivers on the planet's surface? And when did it change to the cold and dry conditions we see today? However, igneous rock is not optimal for preserving the probable traces of ancient microbes that Perseverance is seeking. In contrast, it can be difficult to determine the age of sedimentary rock, particularly when it compares bits of rock that formed at different times before the sedimentary rock was deposited. On the other hand, sedimentary rock frequently originates in aquatic settings conducive to life and is better at preserving ancient evidence of life. Scientists find the sediment-rich river delta that Perseverance has been studying since April 2022 so intriguing. The rover has begun drilling and collecting core samples of sedimentary rocks so that the Mars Sample Return Campaign might potentially return them to Earth to be analyzed by powerful lab equipment that would be too huge to fit on Mars. A second report published in Science revolves an age-old Mars puzzle. Several years ago, Mars orbiters discovered a rock deposit containing the mineral olivine. This structure spreads from the inner rim of the Jezero crater into the surrounding area, covering an area of approximately 27,000 square miles, roughly the size of South Carolina. Numerous hypotheses, including meteorite impacts, volcanic eruptions, and sedimentary processes, have been proposed to explain why olivine is so abundant over such a vast surface area. Alternatively, the olivine may have developed deep underground from slowly cooling magma, molten rock, before being gradually revealed by erosion. Yang Liu of NASA's Jet Propulsion Laboratory in Southern California and her co-authors have concluded that the last option is the most probable. Perseverance abraded a rock to reveal its composition. By examining the exposed piece, scientists identified the olivine's enormous grain size and the rock's chemistry and texture, using Perseverance's planetary instrument for X-ray lithochemistry, or pixel. They estimated that the olivine grains in the area measure between 1 and 3 millimeters, significantly larger than predicted for olivine generated in fast-cooling lava at the surface of the planet. According to Liu, this huge crystal size and its homogeneous composition in a particular rock texture necessitate a very slow cooling environment. Therefore, it is likely that this magma in Jezero did not erupt at the surface. The 2 articles published in Science Advances reveals the result of scientific instruments that help demonstrate that igneous materials blanket the crater floor. The equipment includes the SuperCam laser and the RIMFAX radar imager for Mars subsurface experiment ground penetrating radar. The SuperCam is outfitted with a rock vaporizing laser that can zap a target as small as a pencil lead from a distance of up to 20 feet. The resultant vapor is analyzed using a visible light spectrometer to determine a rock's chemical makeup. During Perseverance's first 10 months on Mars, SuperCam captured 1,450 points, allowing scientists to conclude about the igneous rocks on the crater bottom. In addition, SuperCam employed near-infrared light, the first sensor with these capabilities on Mars, to determine water-affected minerals in the crater floor rocks. However, the combination of laser and infrared studies revealed that the charges were not widespread across the crater bottom. Roger Wiens, SuperCam's main investigator at Purdue University and Los Alamos National Laboratory, stated that the data implies that these rocks layers were isolated from Jezero's lake water, or that the lake existed for only a limited time. RIMFAX is another first. Before Perseverance, no spacecraft on the surface of Mars had ground-penetrating radars. Being on the surface, RIMFAX can provide unmatched detail and has surveyed the crater floor to a depth of 50 feet. Its high-resolution radargrams reveal subterranean rock layers that are unexpectedly tilted up to 15 degrees. Scientists can construct a timeline of Jezero's crater development if they understand the arrangement of the rock strata. As the first such instrument to operate on the surface of Mars, RIMFAX has demonstrated the potential value of a ground-penetrating radar as a tool for subsurface exploration, said Svein Erik Hamran, RIMFAX's principal investigator at the University of Oslo in Norway. The science team is enthusiastic about what they have discovered thus far, but they're even more enthusiastic about what lies ahead. Astrobiology, especially the search for traces of ancient microbes, is a primary purpose of Perseverance's mission on Mars. The rover will study the planet's geology and climate history, lay the route for human exploration of Mars, and be the first mission to gather and store Martian rock and regolith, which is broken rock and dust. Subsequent NASA missions, in collaboration with the ESA, the European Space Agency, would send spacecraft to Mars to collect these samples and bring them back to Earth for in-depth investigation. The Mars 2020 Perseverance mission is part of NASA's Moon to Mars exploration strategy, which also includes Artemis missions to the Moon that'll aid in preparation for human exploration of the Red Planet. JPL, operated by Caltech in Pasadena, California, on behalf of NASA, designed and operates the Perseverance rover. That's all for today's video. If you want to see more videos like this, please consider subscribing to our channel.